Hello everyone, this is Heidi, and welcome back. This is video 2 on the FC1 programming language. In this video we're going to be covering the assignment point and proper formatting structure when coding in FC1. So we have a blank active.fc1 file, and we're going to go back to the hello world script in the last video. Proper protocol suggests that you might think the correct way of writing it is as I described. In fact, it is a correct way, but it's not always the right way, per se. This is more of a quick way of writing a simple program, but it's not the recommended way. The recommended way follows proper structure protocols, which I did not properly show off in the last video. Nothing will particularly change when using structure protocol, but it will adjust functionality of the program, so to speak. So we have the Hello World script, one of the more basic Hello World scripts FC1 provides, like so. But we're going to modify it ever so slightly. And the way we're going to do this is we're going to use the assignment point. And a little bit like C++, or any programming language really, and in which we're calling an object, or an objective, you could say. So I'm going to put this all back a ways, and in front of it, I'm going to put a star here. I'm going to put this @ symbol, and this is called an assignment point. Assignment points have to have a label, and what they are is they're basically access points that the language registers and looks for in the case of particular statements. And they're used as points that the language can access at any given time. So if I put the assignment point here, on the next line I have to name it. I should note assignment points do not accept variables, so I cannot put a string in there. I have to put a text line of some form. It can be numbers, it can be anything, but something identifiable that won't show up under any other assignment points, so make it unique. The first, if for example, I'm going to call this one main. Now it should be noted that after main there is a blank line here. Now when we're using it, you have to leave this blank line open, and there are reasons for it. You can hide script here that access as you pass through, but as soon as you run a statement that calls this, it'll skip over. Things like that. But what we're going to hide in here is the reverse of the @ symbol. The reverse assignment point, the assignment, the closed assignment point. And your compile structure will just skip over these by default. They aren't really equal to anything when you run the program. They aren't really recognized, so to speak. So we have our hello world statement here. And if I bring the assignment point back up, you will find that this is going to execute exactly the same as previously. But we're not really done with it, because we're still structuring this accordingly. And because we have it called main, we've effectively created the primary function, so to speak, of the language. So normally what I would do in a situation like this is I would call another line here, and I'm going to put another assignment point reversed like this. And that's because the function we're going to use is going to skip this line, and we need to find a way to to break it. So we're going to do that by using another closed assignment point. We can't leave the line blank in 3, so we have to fill it with something. And to fill it with something, we need a neutral command that does nothing. And there are a few options we could use. We could use a debug point that will result in something. We could use a comment. The issue with a comment is when you have a comment, you have to put something in the comment, and you have to close the comment. But this closed comment will not be skipped, and so it'll land right here, and it'll hit an error because this is not recognized as a closed comment is not recognized. So what do? We click the fastest function that we can find that's available for something like this, and that is the reverse assignment point. Like so. Assignment points are not indexes. They are, the name basically describes them. They are a point that you assign. That you assign your process to, and we're going to be using these a lot in FC1 for proper structure format. And in the early stages of FC1, we may not use them as much, but it's better to introduce them now rather than later. And I can put any name in here. So I'm going to move this back a ways. Now, this isn't going to run very well. It'll run perfectly fine, but if we put in the debug, we got some error going here. And that's because it doesn't like blank lines. FC1 does not like blank lines. So we're going to counteract this by adding some code above. And we can leave some blank lines in between here, it's fine. It's still available for structure purposes. So here's what we have got. So I'm going to start by in this star. I'm going to call the control stream. On the next line, I'm going to put this in. I'm going to say go to. Now this is not like your typical go to in batch script or any other language. You don't assign it the same way, and it functions fundamentally differently. But we're going to tell it what it's looking for, and it's going to look for main in this case. And we can have other mains in our code. It's looking for an assignment point, and then it registers what the name of the assignment point is. So this code here will still result, except it closes. So working with goto functions is a little how should I put it? Sorry about that, quick cut. So as I was saying, they work interestingly. So running something like this one might expect to work, except it's pretty obvious what's missing in a situation like this. And you can see it right after this assignment point, the second assignment point. And that is, after it, we're missing the close. So when we had it up before, it worked. It worked just fine with just this assignment point here. And the trick with this is, we like to hide, we like to put this in here, because we have to close the control library after we run our goto statement. So we've gone to main, and we've exited the goto statement. And you may think, oh, well, now I'm done, we're back in the index, but we're not back in the index. We may have closed the assignment point with goto, but we have not, functionally speaking, finished the main sentence. So we have to leave the index before we can output our hello world. The reason it crashes immediately, if we don't, is because it gets stuck on I, and then we'll loop until it cacks and runs out of error adaptation. And this will cause the program to crash, and in a very unsafe way. It'll leave all your memory in RAM, so not a particularly good thing. And these are faults that we have to look for when writing an FC1. There will probably someday be a correction for this, but for now, for debug purposes, there is none. So I'm going to run this, and we have hello world. If we check the debug menu, you can see there are no errors, and there's no deprecations, and everything works good. And this is the power of the assignment point. It allows us to block things, so to speak, and put things into chunks. And in proper form, we would have a main statement that we'd be able to access at any given time. So now you may be wondering, what's the point of the hidden line? Well, it's ignored by the goto statement for a reason. And that's because if we were to call this without the goto statement in place, this would be an error statement, an error level class statement, because we have an open-ended here. And this would give us an error. It wouldn't close the program, so to speak, but it wouldn't run correctly. How do we combat this? Well, we have to have an extra line that the goto statement can't find. In this case, that's the line after the title. So what do we do for this? We open it. And this is a recognized function in control stream, and we're completely safe now. And that is the purpose of that third line in the statement. No errors. And so if we re-add goto statement up top, this C plus goto main. Got dangerous error territory and this thing right there. But if we run this, there's not an error to be found. And that's the purpose of the hidden line in a goto statement. So now there is more to this, and we're going to expand this. We're going to rename this here to alpha. And then we're going to have another assignment point below us called beta. And beta is also going to have this hidden on the line and an assignment point, a reverse assignment point hidden afterwards, along with the closed stream. And this is going to output, our line is going to output in alpha, and this is going to, there will be a special IDE for this later on. Output line in data underscore ret close I plus terminate reserve stream and underscore debug. So we have alpha and we have data. And we haven't learned the mathematical library yet, but it's going to be a component that you would use in something like this, but we're not going to focus too heavily on it right now. Before this C statement here, we're going to use a different library. And this is a library called, so to speak, it's called the variable library. We're going to use the variable library. And we're going to allocate a Boolean. No, we're going to just use an integer 1. allocate one integer, and we're going to close the allocation. And we're going to set the storage value of integer 0, because of the previous transfer rule. And we're going to set it to equal 86. We're going to say, and we're going to return, and we're going to close the variable stream. So 86. So we're not going to use this go to main statement anymore. We're going to use something else. We're going to say plus if, and we're going to write an if statement in the FC1 way. So I'm going to say if, and then I'm going to specify a type of if. So underscore var, and then we're going to specify the type of var, and we're going to say int, and then we're going to say the type of int. We're going to say int var 0, and now we have a whole host of things we can do. But in this case, we're going to just use two equal signs. If variable int is equal to, and now we're going to have to specify another type. So I'm going to bump this up to 2. I'm going to store here underscore int 1 is equal to also, I'm going to scrap this actually, and there's a slightly more complex route that I was trying to avoid, but we're going to do it. Equals stream. So there's a few other statements we can use in this spot here for integers. There is underscore EQU for equals, but we can use this operator here, not 1, 2. There is the not equal. There is greater than or equal to, and less than or equal to. There's also less than. If we wanted to write a greater than or equal to statement, we could say underscore moe, M-O-E, and it is more or equal to, so to speak. And anyways, equal to stream, and then we just get to write in the stream, and we're going to say if 0, so that's referring to this, not this. If integer 0 is equal to 86, then go to, see this, go to underscore alpha. And now we have a stream here. So we're going to close the previous one, and we're going to open this, and we should get, and it crashes. So let's figure out what exactly went wrong and why it crashed. I'm really dumb and put an underscore in front of my alpha. So yes, add the I guess we don't really need that. Okay, there we go. That should work. Yep. Okay. So put underscores in front of things that don't need them. Word of advice. That was pretty dumb. In my own language too. Anyways, that is the if statement in a nutshell. I will be providing documentation for this very, very soon that will support everything I'm saying, and will allow you to experiment a little with libraries. The way the documentation is going to be set up is in pattern, is in the basic structure. It's going to specify in the index, and then it's going to say here are the libraries in the index, and it's going to say like, hey, you want to enter the allocate library, and then it will have something that says like and then we'll give you an option of all the things you can allocate. So underscore int, and they'll all be lined up one after the other, And then after that, it will say A1. And this means action line. So it's the line that comes after it. And then in there, it'll say brackets. And it'll say number of ints you want to allocate. Like this. And all you have to do then is just, instead of saying A1, you can say just allocate 1 or 2 or 3 or 1,000. So on and so forth. That is how the documentation structure will work. Putting that out there now so you know how to use it when it's released. Anyways, so what if we said 42 instead of 86 or something like that, and then we ran this. Then we've got in alpha here, but we've got an error going for us right now. And here's why. Everything went off as expected. We said go to alpha, and it looked for alpha and didn't find it. So what if we said not equal to? In this scenario, there will be no errors. But if we said equal to and doesn't find anything, where does go after that? Well, it keeps going. And it immediately escapes all the locations, escapes all this, and outputs alpha anyways. So on. So anyways, now you know. You probably need to build a failsafe in here also, in case it fails. So on the off chance you don't find what you're looking for, putting an underscore ret back here is not inherently a bad thing to do. And then just closing this to ensure that you output correctly. Because then you won't get an error and such. That's that. Yeah, now you know how it all works. This is Contrari, and I will see you later. To end it there, but I wanted to explain something. When something like this fails, it skips these lines, and it continues on afterwards like this. And just you should know that. So yeah, extending on that again. So if it fails, just put 2 lines in the back here. Give it a bit of space because it's going to skip these 2 lines. There will probably be a fix for that later, but current versions, that's 0.0.3 build R. It's going to skip these 2 lines. So that's how you ensure it doesn't spit out in alpha at the end. Note if I leave these 2 in, it skips right over, closes this, gets a bunch of errors, and doesn't go as well. Yeah. So follow protocol, kids. It's worth it. Yep. Well, I'm recording another one of these, so yeah. There is actually another piece of information I'm leaving out here, but there is actually, after something like this, a statement you can use. It's called the else statement, and I can say if is equal to 42, go to alpha, but else underscore go to beta, and that's a freaky title, freaky work. Don't you agree? Yeah. So else go to beta, we'll end up here. So if we run this, it's in beta. But if it is value of 86 stream, then it's in alpha. Yeah. So that's why if this isn't here, just skip 2 lines, say underscore ret, and close your program. Yeah. That wasn't well explained. I'm sorry. Or go to beta. I should really do this better. I should actually mention another thing actually, and that's that if I was to have allocated two integers, I could actually in here store int 1 to be 42, and I could say instead of stream, I could say if it's equal to 1, because it's still an integer and I can't use an int64 or anything like that. So I could say that statement, and it's going to get to output in beta. See, it's in beta. But if I set this to 86, and then it compares it to that integer, and you have an alpha. Yep, that was that.